hiding signature-based broadcast encryption. Okay, so actually I said it wrong. We don't need signatures anymore. So we're just going to use broadcast encryption language. The protocol goes like this: if the trapdoor is the private key in the broadcast encryption scheme, for which the public key is the authority of Alice, and private keys in the broadcast encryption schemes, they are tagged by some sort of identity, okay, like first, second, third, and fourth, okay, simply speaking. The identity is necessary because the certification, the authority that issues these private keys has to know, has to somehow associate them with identity so that to be able to revoke them. Okay, but nobody else needs to know these identities. So it's only the organization itself knows it. They are not visible to the outside. So I should mention, I don't have a slide for it, what broadcast encryptions really are. So a normal encryption is that you have a public key and corresponding to it a single and unique private key. Okay? And if I encrypt something, I encrypt under the public key. The only person who can decrypt it is the possessor of the unique decryption private key. Broadcast encryptions have differ from that as follows. There is still one public key. So when I encrypt under a single public key string, but to which there actually might correspond multiple private keys that are, and not everybody can come up with them. The only person who can come up with them is the owner of some sort of super key that corresponds to this encryption key. Okay, so there is a super master key from which all the different private keys can be derived. So if I'm an owner of the group, I can issue each of you a decryption key so that when a message is encrypted under our group public key, each of you can decrypt it. Okay? So why don't I just simply use a normal public key encryption and just give you the same decryption key, right? So I just replicate the same decryption key, give all of you the key. The reason is that I won't be able to revoke any of you. Okay? So using standard encryption, the trivial solution, right, is not a good system, because once I gave all of you the same decryption key, how am I able to kick any of you out, right? Sorry for the language, right? So broadcast encryptions you can differentiate. So everybody has a different private key, and moreover, there is something called a key update message, okay, which I can broadcast to the whole world, put it up on my website. And the key update has the following property. Everybody who is not revoked can update their current private key, okay, so that they can still decrypt messages. And moreover, the public key of our group is also updated by this key update message, okay? Therefore, everybody who from now on encrypts for the group uses the key modified by the update. So the one person who was revoked cannot read it. Everybody else, because they were able to update their private keys, can read it. And so forth it goes. And it should be constant state. So I don't need to remember all these update messages. It's an active thing. I consume the update message, change the public key. If I'm an encryptor, I consume the update message by changing my private key if I'm one of the still non-revoked group members. So I will use this terminology because of key update messages, the private keys, and private keys and the public keys. So now, having the broadcast encryption scheme, I proceed as follows. Alice encrypts some nonce that she chooses under the public key of the CA2 group. Bob encrypts nonce of his choice under the CA1 key of the other group. Now, if Alice is a member of CA1, she should have the valid, still unrevoked private key. So she should decrypt this NA, let's call this decryption NA prime. And if Bob still has the unrevoked private key for the CA2 group, he will be able to decrypt this nonce. Sorry, I said it wrong. Her nonce that she decrypts is called NB prime. He will be able to decrypt this nonce, call it NA prime, and from after that, there is standard key agreement. So this stands for authenticated key agreement. So they can authenticate each other by just checking, do we have the same nonces, okay? And this is standard how authenticated key agreements work, and this also does not reveal anything. So if you don't have the, if you guys don't have the same nonces after this point, you will not learn. Maybe you have some other nonce. I don't know. I will not learn anything. And this is the standard key agreement protocol that does this. So the only thing we really need to worry about is this part. So I said that the CA really includes all the revocation information, all these key update messages, and also the private keys will include the revocation information because I'm assuming the users update them. And the broadcast encryption needs to be affiliation hiding, meaning, again, the broadcast encryption should hide the what key was used, that Alice used, and that's it, really, because, well, unless it's an interactive broadcast encryption, but actually it's not, okay? So we have a non-interactive broadcast encryption. So basically, that's really the only thing we need to protect. And the unlinkability follows, okay? Because if this broadcast encryption hides the public key that is used, then that's it. There is nothing else that can be linked in here, because every time I use a different nonce, and therefore I have an unlinkable scheme. I don't have that much time to go through the construction. I will only mention maybe that how does it sort of roughly work. Essentially, I will be sorry, I was going a little slow. The way I will encrypt, well, why don't I just show this full solution, okay? So this is the solution that does work, okay? Okay. The broadcast encryption that I use, okay, will be sensitive to I call delta, okay, the maximal. I should have actually said this earlier. So the protocol becomes trivial if you assume that everybody is fully updated all the time. So because that's how broadcast encryption schemes work, that if we all consume all the key updates that are issued, so we all updated our decryption keys, that really means that we all have the same decryption key, okay? So there is some sort of master decryption key that we all share. And therefore, the encryption, broadcast encryption is just a very simple thing. I take the master encryption key, encrypt something for you. You have the same key because you're still not revoked, and you are perfectly updated. So you have the current master decryption key. You decrypt it, okay? So the protocol is basically like shared key authentication. We share the same key, and so we can privately authenticate each other because we use symmetric encryption, which does not reveal what key is used. But this is not a very practical system, okay? Because in any kind of group management,